For example, okay, like look at this one, today's lesson. This is a today's lesson. Integration part is another technique that is very useful for product of algebraic and transcendental functions. So these examples below, that you can see it, we do not know how to integrate these given function problems. So we need a new technique. Okay, so we need a new technique. Look at this. I gave you x, natural log of x. Look at the x and natural log of x. How would you integrate this? We have not learned this. How I'm going to integrate x squared and e to the x? We do not know how to do it. We know how to do x squared. We know how to do e to the x separately. But into multiplication, we haven't learned how to do multiplication. We already know what. We only know what. If it's a what? Addition, we know how to do it. But it's not addition. Look at this. It's connected by what? Multiplication. So we do not know how to do it. And we do not know how to do e to the x and sine x. That's the reason that we need to learn new technique. Okay. Nice about calculus, they all teach you like, okay, you have a problem with this, I'll show you new power. Like whenever they introduce you a new technique, it's like giving you a new power. Okay. Okay. So integration by parts, it is actually based on product rule. Okay. So if I give you derivative of two functions, u and v, what is the product rule says? First times what? Derivative of a second function, right? Plus what? Second function times derivative of a first. So this is a product rule. This is just a simple product rule. Product of u times v. So how would you do? First, this is a first. This is the second function. So first times what? Derivative of a second plus what? Second times derivative of a first. That's just the product rule. So we use applying this, okay? And I'm gonna rewrite dv dx as what? Just to say v prime. Are you with me? And I write down du of dx as what? U prime, right? That is true, right? dy dx, remember? dy dx is the same as what? Y prime, right? Same concept apply. Okay, now we're both u and v is what? Differential functions, just a differential function. Differential function means it's a continuous function. All right, now, so I'm gonna rewrite this by taking antiderivative. So if you take antiderivative, so I apply what? Antiderivative of each expression. Okay, so then derivative and antiderivative what? Cancel out. So you just have a uv. It's equal to now. So you have, okay, this just so you're writing down these problems right now here. Now look at this. You rewrite this as a dv dx. You write down u as dv dx. Okay. Then you can see like dx and dx cancel out. So you have what? U times dv and plus what? V times du. So this right here, which is came from product rule, I'm gonna rewrite it. I'm gonna rewrite this part. I wanna put that to be in the front. Okay, I want you to bring this one to over here. Then what do you have now? Okay, this is the one that we're using about integration by parts. Darian, yes. Right. No, so we're not. So the part right here that I explained, this part right here, I'm just letting you know how I got this formula over here. But this is the formula we're gonna use on 8.2. So this is called what? Integration by part, because you make it into what? Two parts. Is everybody with me? Your problem, which is this, I'm making it into what? Two parts. So this is how you do it. You have a derivative of u times dv is equal to u times v minus what? Derivative of v times du. Let me explain to you what they are. I will go over 3 examples with you. Okay, Everybody with me? Okay. So look at the theorem first. Theorem, integration by parts. If u and v are functions of x and have a continuous derivatives, then you can write down as integration of u dv is equal to what? uv minus what? Integration of what? U times dv. I mean, v times du, excuse me. All right, now I need to explain to you what to choose as your u, right? Because you need to know what is u and what is dv, right? Otherwise, you don't know how to solve dv or v times dv. So I'll explain to you. This is very important. This is a guideline. It's not always true, but this is a guideline, okay? So guideline means what? It kind of give you frames what to do, okay? You don't know what to do. You have a street post that says right turn, then you know, look at the street name and then you take a right turn, right? That's a guideline. So I'm giving you guidelines. What's the guideline? It says, try letting what? dv be the most complicated portion of integral. Okay, and also it has to be what? This basic integration rule. The basic integration rule is the one that we reviewed. Remember 1 through like 20 of them that I reviewed? Those are the basic integration rules, okay? And then the other, it has to be what? U. So when you see a problem, you have a u and dv. So you want this dv to be what? Complicated one. But it has to what? Meet what? The basic rules, right? Okay, that's the important part. Okay, what's the next one says? Try letting u be the portion of an integrand whose derivative is a function simpler than u. Okay, so main thing is this. All right, let's look at the example. Oh, also this is common one. They also gave you common integration. So you can just look at this and you can kind of match it. Okay, this is a very common one. So look at this. If you have x to the some power, e to the some power, what did they tell you? Use what? U to be x to the what power, and dv to be what? E to the whatever the power. Okay, dv goes with the what? Dx. So dx belongs to dv. Okay, are you with me? Okay, what is another one they told you? If you have x times what? X times natural log. X times natural log. Then x is what? U. Oh, the natural log to be what? U. And then the other one to be what? dv. Okay, so this is a little bit, that's why I'm gonna give you this. I'll give you this, okay? But you need to kind of familiar with this. So what you just learned, if you have some x to the say 2 and e to the say 4x dx, it told you to use u to be what? X to the 2 and dv to be what? E to the 4x dx. Are you with me, class? It gave you a hint. Watch another one, it says. If you have, say if you have x to the 4 and natural log of x dx, what's u in this case? No, look at this. What did they say? Natural log to be what x? Because when you do that, the reason is, okay, if you do this, if you have a natural log of x, okay, do I have? Let's go back. That's a very good question to ask. Let's go back. I'm gonna look at our basic integration. Okay, let's look at the basic integration. Do you have a natural log of x as your basic integration?
Yeah.
Where? What number? No, number 5 is not. Number 5 is what? I have 1 over u. Du gave you what? Natural log of u. It's not natural log of u du. I don't have that as a basic integration rule. Does everybody see me? Why I'm not using natural log of u as my dv? Okay, because it doesn't have a what? Basic integration rule. I don't have that. I have 20 of them. So whenever you do your problem, just look at your 20 basic integration rules. If it's not one of them, you cannot use that as your what? dv. Okay, so everybody see that? So let's go back to, this is a very important part. So if you understand this, your homework problem gets much, much easier. So now looking at this, you're looking at this and you're gonna say, okay, because I don't know what this is, right? I cannot use that as my dv. So my dv has to be equal to what then? X to n, and then u has to be equal to what? Natural log of x. Does it make sense to you now? All right, number 3, there's one more. If you have e to the something and then what? Sine of some function, then what do you do? What do you choose as u? Sine. The trigonometry function become a u, and the other one become a what? E. Because there's 3 things. If you know these 3 common integrations, then your homework problem is much easier for you. All right? Okay. So let's look at the example 1. Okay, so example 1. Which one does it look like? There's a common intervals. Which one looks like? RM1, RM2, RM3. That looks like to me number 1, isn't it? Look at this. The problem that I want to solve is x to the y, e to the x dx. So let's look at this one again. So which one does it look? The problem that we got to do is x, e to the x dx. So which one should I use? 1, 2, 3. Which one looks like to you? Definitely 1, right? Then if that's so, then my u has to be equal to what? X. What's my dv? E to the x dx. Is everybody with me? Okay, so everybody agree? Okay, because that's the main part. If you can figure out what's u and what's dv, 50% is done. Okay. Okay, as I said before, I gave you steps, but I want you to remember this. Okay, I'm going to apply guidelines and then what? Common integration by parts. Okay, so my first answer. Since the given problem is similar to what? A summary item, what? 1. Is everybody with me? Did you see I said what? Why am I choosing u to be this? Why am I choosing dv to be this? Did I explain to you why? Yes, I did. I said because it's a common summary says 1 is this. So when you do your homework problem, you need to tell yourself, okay, I am choosing u to be x. I am choosing dv to be e to the x because of what? The common integration rules. Okay, now then, remember the formula. Formula says what? U dv, and then equal to what? U times c minus what? And then what? V times du. So we know u, we know dv. Can I find du? Can I find the v? How can I find du? By doing a what? Take a derivative of this, right? What's that equal to then? Just simply 1 dx. How can I find the v from dv? Take what integral? So I'll take integral of e to the x dx. What is that equal to? E to the x is the same as what? E to the x. Now, can I plug into my formula? The formula is what this. All right, so tell me what's u. U equals x. What's v? E to the x minus what is a v? E to the x. What's du? 1. I'm done. So my answer is x, e to the x. Take antiderivative of this. What e to the x is what? E to the x plus c. So you just figure out. Okay, so step 2, what did the step 2 says? Utilizing this. Okay, utilizing this to find what? Du, and then find what? dv. Okay, is everybody with me? Okay, so nothing more. Now what do you do? After that, what do? You just simply plug into what? Your formula. Like just like what I did on your right hand side. You see? After I figured out my u, remember u and dv, I use the guidelines, common integration. What do you about this? This is what you need to do. You calculate it. You calculate this. Are you with me? This one you figure out using a common rule. This what you do. You find it. Are you with me, class? You find the du, you find what? V. Okay. So that's example 1.